In this video, we'll be starting with a simple quadratic function, f of x. We'll find its inverse function, f inverse of x. Then we'll look at the composition of these two functions. Start by creating a Desmos window. You may want to log in. Graph y equals x, which is a line that crosses the origin and has a slope of 1. The reason for this graph is that functions and their inverses are mirror images of each other across the line y equals x. Now we're ready. So let's start by graphing the function f of x equals ax squared. F of x equals ax squared. You'll be asked if you want to create a slider for a. You do, so click the blue button. This is the graph of a parabola with its vertex at the origin. By default, a is equal to 1. Go ahead and change the value of a. Try these cases. A greater than 1. See how the parabola gets narrow? Now try a in the range between 0 and 1. So, for example, 0.5. See how the parabola gets wider? And now let's take a look at a less than 0. So a is a negative. See how the orientation of the parabola changes? So let's set a back to 1. What does the mirror image of this parabola look like reflected across y equals x? Input this equation to see the mirror image. Ay squared equals x. Ay squared equals x. To make it easier to see, turn off this parabola. This looks like a parabola on its side, but notice it is not a function. Do you see why? This graph does not pass the vertical line test. In other words, a vertical line crossing this parabola would intersect the parabola at 2 points. That is not allowed for the graph of a function. The inverse should basically be half of this parabola, either the top half or the bottom half. So let's go back to the original function. Get rid of this non-function and turn on the original function. F of x equals ax squared. We need to limit the domain of this parabola. Let's limit the domain of this function to values of x greater than or equal to 0. To do so, input this, brackets, x greater than or equal to 0. Now you see only half the parabola. To see the inverse of this function, input this function, g of x equals the square root of x over a. G of x equals the square root of x over a. Now you can see the parabolas as mirror images of each other. In fact, you can animate the slider for a to see the different quadratic functions and their inverses. But let's look closely at a. Notice that the slider allows a to be negative. Let a equal negative 1. In g of x, the value of a is negative, but the square root of x over a is positive. Why? Notice that when a is equal to negative 1, all values of x are negative. That's why the term under the square root is positive. A negative divided by a negative is a positive. But didn't we restrict the domain of the function to non-negative values of x? Yes, but only for f of x. There are no restrictions on g of x. In fact, we don't need to restrict the domain of g of x once we've restricted it for f of x. So the inverse of even the simplest quadratic function needs limits on its domain in order to find the inverse of this function. What does the graph of f of g of x look like? Input it and see the graph. F of g of x. The graph overlaps the graph of y equals x, but only partially. Now look at g of f of x. G of f of x. You get the same overlap with y equals x, but only partially. In general, if f of x has inverse function f inverse of x, then the composition of these functions is x. In other words, f of f inverse of x equals x.